Hey, welcome back to AI with Sheetal. Hi guys, this is Sheetal, and I hope you all have been waiting for this video because today we are finally here and I'm so excited for this one. So, first of all, a huge thank you to everyone who watched my video very first. The response was honestly amazing, and I know so many of you left the comment saying, Sheetal, when is the next video coming? So here it is. We are starting a strong. Now, before we jump in, I just want to say something. You do not need anything special for this video. You don't need any prior experience in AI. Even you don't need a PhD. You don't need to be a software engineer with 10 years of experience. All you need is you, your laptop, and your focus. That's it. And I promise you guys. So, what are we covering today? Great question, and this is a big one. Okay, so this video has two major parts. So, the part first, I'm going to walk you through the core AI and machine learning concepts that you absolutely must understand before you start building Gen AI apps or RAG systems. And trust me, guys, a lot of people skip this part. They jump straight into code and then they get confused. But we are not doing that. We are building the foundation first, and in the part second, I'm going to completely break down a RAG for you. What is the RAG? Why does it important, or why does it even exist? What are its 5 main components? How does the full architecture work? And where does the RAG fit in the bigger Gen AI and agentic AI world? So by the end of this video, and I mean this, you will have a crystal clear mental model of the entire RAG world. No confusion, no gaps, no. I kind of get it, but not really. You will actually get it. So if you're ready, so grab a coffee and sit back and let's get into it. And one more thing I would like to add, guys, if you haven't subscribed yet my YouTube channel, so please do that right now and hit the bell icon too, so you don't miss the next video where we are actually build a complete RAG app from scratch, live coding and end-to-end implementation. Okay, so let's go. So concept number 1, what is machine learning? Okay, so do you know how we normally write computer programs? Like traditionally, we write if this happens, then do this, else do that, rule by rule, step by step. We tell the computer exactly what to do in every possible situation. Now imagine you want to teach a computer to recognize photos of dogs. Okay? If you think about it, how would you even write evil for that? Like if the image has 4 legs and fur and floppy ears, then it's a dog. But wait, what about cat? A cat also has 4 legs and fur. And what about a dog that's been groomed in a funny way? You can't write rules for every possible dog on the planet. That's impossible, right? So that's where machine learning comes in. Instead of writing rules, we feed the computer thousands of examples, thousands of dog photos, thousands of non-dog photos, and the computer on its own figures out the patterns. It learns by itself from data. So guys, think of it like this. You don't teach a little kid what a dog exactly looks like by listing every single feature of every dog breed on earth. You just show them pictures. Look, dog, look, dog, look, cat. And after enough of the examples, they get it. So they can recognize a dog they have never seen before. Simple, that is machine learning. So now, why does this matter for RAG? Here's the connection. The entire intelligence inside a RAG system, the model that reads your question and understands it and generates an answer, is a machine learning model at its core. Everything we build on top of RAG is possible because of machine learning. So, this is your starting point. I hope you understood what is machine learning. Okay, so concept number 2, which is deep learning and neural networks. So, machine learning is a big umbrella. Deep learning is a specific type of machine learning that uses something called neural networks. And neural networks are loosely inspired by how the human brain works. Now, don't let that scare you. I'm not going to go into a neuroscience here. I promise, guys. So, here's this simple version. A neural network has layers. There's an input layer where data comes in. There are hidden layers in the middle where the data gets processed and transformed. And there's an output layer where the result comes out. So guys, imagine you're baking a cake. You put your raw ingredients in. That's the input, right? So it goes through the oven, multiple stages: heat, chemistry, then transformation, and what comes out is a beautiful cake. That's roughly what a neural network does. Raw data goes in, layers of transformation happen, useful output comes out. So now, here's why this matters for you. Every modern large language model, GPT, Claude, Gemini, is built on a specific type of deep neural network called a transformer. So when you use RAG and you're using an LLM to generate the answer, that LLM is a deep learning model underneath. So you don't need to build this from scratch, but knowing this exists, that gives you a real understanding of what's happening under the hood. I hope guys you understood what is the deep learning and the neural networks. Okay, so concept number 3, which is embeddings. Okay, so I want you to really pay attention here because this is probably the most important concept for understanding RAG. Are you ready? This is embeddings. So here's a question for you guys. Computers are great at working with numbers, right? But text, human language, computers don't naturally understand words. So how do we bridge that gap? How do we take text and convert it into something a computer can actually work with mathematically? So the answer is embeddings. An embedding is basically a way of converting text, a word, a sentence, a paragraph into a list of numbers. We call that list a vector. And here's the magical part. Similar meaning equals similar numbers. Let me give you an example. If I take the sentence, I love dogs. Okay, so please guys listen the sentence carefully. If I take the sentence, I love dogs, and I convert it into an embedding, so I get a list of numbers like maybe 384 numbers you can consider. If I then take the sentence, I adore puppies, and I convert that into an embeddings, I get another list of 384 numbers, right? So now, even though those two sentences use completely different words, their embeddings will be very, very close to each other mathematically because the meaning is similar. Do you see that? Now compare that to a completely unrelated sentence like the stock market crashed today. See, once again I'm repeating the sentence for you. The stock market crashed today. That embedding will be very far away from I love dogs. I hope you're getting my point. Because the meaning is totally different, right? Think of it like a ruler, but instead of measuring distance in centimeters, we are measuring distance in meaning. Close on the ruler means similar meaning. Far on the ruler means different meaning. That's what embeddings let us do. I hope you understood. Now, why does this matter for RAG? This is everything. Here's the connection. In a RAG system, when user asks a question, we convert that question into an embedding, a vector, and then we search our entire document in the database for chunks whose embeddings are closest to the question embedding. Right? That's how we find the most relevant content to answer the question. So guys, see, simply embeddings are the heart of the RAG. It means retrieval system. Without embeddings, no retrieval. Without retrieval, no RAG. So if you take away one concept from this section, let it be this one. Okay. So concept number 4, large language models, or we can say LLMs. Okay, so I'm guessing most of you have used ChatGPT at some point, right? So ChatGPT is powered by large language model. GPT-4 is an LLM. Claude is an LLM. Google's Gemini is an LLM. Meta Llama is an LLM. So these are all examples of the same category are large language models. I hope you understand. So what is an LLM exactly? It's an AI model that has been trained on absolutely massive amount of text data, and we are talking hundreds of billions of words from the internet, books, articles, code, you name it. And through that training, it has learned to understand human language, generate text, answer the questions, summarize the content, write the code, have conversations, and much more. So now here's the key thing I want you to remember, guys, about LLMs in the context of RAG. The LLM is the final brain. It receives your question along with the relevant document chunks we retrieved, and it generates a human-like answer. But, and this is a crucial, the LLM does not retrieve information, it generates. The retrieval is handled separately. The LLM just takes what it's given and produces a response. That separation, retrieval over here, generation over there, is actually what makes RAG so powerful. And we'll see this super clearly when we go through the architecture. So keep that in mind. So concept number 5, which is vector databases. So guys, you have probably heard of databases before, right? Traditional databases like MySQL or PostgreSQL or store structured data, rows and columns like a giant Excel spreadsheet. You can search by a name or date or an ID, that kind of thing, right? But here's the problem, you can't search a traditional database by meaning. You can't say, find me all the roads that are similar in the meaning to this question. It doesn't work like that, right? So that's where vector databases comes in. A vector database stores embeddings, those list of numbers we talk about, and it's specifically optimized for one job, similarity search. You give it a query vector and it finds the most similar vectors in milliseconds, even if you have a millions of documents stored. Okay, so some popular ones you will hear about Face, which is a great for local development. It runs entirely your computer memory. ChromaDB, which is perfect when you want to save your embeddings to disk so you don't have to reprocess every time. Okay, and the Pinecone and VV8 for production at scale. So in RAG, the vector database is your memory. You store all your document chunks there, and every time a user asks a question, then the vector database is where we go searching for the most relevant answer. It's the retrieval engine of the entire system. I hope you understand what is the vector database. Concept number 6, the transformer architecture and the attention mechanism. Okay, so the transformer is the architecture that all modern LLMs are built on. It was introduced back in 2017 in a famous research paper, and I love the name of this paper. It's called The Attention is All You Need. Brilliant name. So what's the key idea? It's this thing called the attention mechanism, and the idea is that when the model is generating each word of an output, it learns to focus on or attend to the most relevant part of the input. It doesn't treat every word equally. It figures out, okay, for this specific word, which parts of the input actually matter. Okay, let me tell you. So here's a simple analogy. Imagine you're reading a really long article, maybe 10 pages, or say something, it might be 20 pages, and someone asks you specific question about it. Your eyes don't reread every single word again equally. Okay? So they jump to the relevant paragraph, the relevant sentence. That's the attention. Your brain filters out the noise and focuses on what matters. So that's what the attention mechanism exactly does. And that's why LLMs can handle long, complex prompts and still produce relevant, coherent responses. You don't need to implement this yourself. Not at this stage, but knowing it exists gives you a real appreciation for why these models are so capable. I hope guys you understood what is transformer and the attention mechanism in RAG. So concept number 7, which is prompt engineering. So prompt engineering is simply the skill of writing the right instructions to get the best output for an LLM. That's it. It sounds simple, but it's genuinely one of the most powerful skills you can develop when working with AI, which is artificial intelligence. Here's a quick example. Let's say I ask an LLM, tell me about dogs. So I'm going to get a very general, vague answer. But if I say you are an veterinarian, so in bullet points, explain the top health risk for golden retrievers in a simple language for a first time dog owner. Now I'm going to get a very specific, structured, useful answer. Then same LLM, completely different output. The only thing that changed was prompt. So now in RAG, prompt engineering is a massive because after retrieval, we take the user's question and take that retrieved document chunks and we combine them into a structured prompt that we send to the LLM. How you write that prompt, how you structured it directly affects the quality of the answer. A badly structured prompt, vague, confusing answers. A well structured prompt, precise, accurate, grounded answer. As you build more RAG systems and more AI apps in general, prompt engineering is going to become one of your most powerful tools. Trust me on that. Alright, so that's all 7 concepts. Let's take a breath and give yourself a pat on the back. You just covered a 7 fundamental AI concepts that most people don't properly understand. Now let's talk about the RAG. I hope guys you completely understand all the 7 concepts which I explained you very well. Okay guys, so let's understand what is RAG and why it exists. So now that we have the foundation, so let's talk about the RAG. And I want to start with the story of why RAG was even created. Because when you understand the problem it was solving, everything else makes perfect sense, right? So RAG stands for Retrieval-Augmented Generation. Once again, I am repeating for you. RAG stands for Retrieval-Augmented Generation. So let's break that down super simply. Retrieval, it means we fetch the relevant information from somewhere. Augmented, it means we add that information to the LLM's input. And the generation, it means the LLM generates the final answer. That's the 3-word summary. So RAG was introduced in a research paper by Meta AI back in 2020. And the reason it was created, one specific problem. So here's the problem. LLMs, as incredible as they are, have 2 big limitations. First, they have a knowledge cutoff date. GPT-4 was trained on data up until a certain point in a time. After that date, it doesn't know anything. It's like asking someone who's been on deserted island for 2 years about current events. Then they just don't know, right? So second, and this is even a bigger, LLM have never seen your private documents, your company's internal reports, your product manuals, your research papers, your customers' data. None of that. It was never a part of their training. So you can't ask an LLM a question about your specific documents and expect a good answer. Understood? So now you might be thinking, okay, Sheetal, can't we just give the LLM all our documents to read, like paste in the whole thing? Well, kind of. But imagine your document is 500 pages long. You can't paste a 500-page book into every single conversation, right? So that's impractical, that's expensive, and most models have a limit on how much text they can process at once. I think you are familiar with this thing. So another option is fine tuning, which means retraining the model on your specific data. That works, but it costs thousands of dollars and takes a days to do. Not exactly something they can't they can do every time your documents get updated. So the people at Meta AI had this insight. What if instead of putting the knowledge inside the model, we put the knowledge beside the model and just retrieve the relevant pieces on demand? Every time someone asks a question, find the relevant document first, then give those documents to the LLM along with the question, and let it generate an answer based on real specific information. So that is what a RAG. Elegant, cost effective, and incredibly powerful. The main purpose of RAG is one sentence is to give LLMs access to external, up to date, private knowledge without retraining them. This makes AI systems accurate, grounded in real facts, and specific to your use case. No hallucinations from guessing, real answers from real documents. So, I hope, guys, you all completely understood what is RAG, what is the main purpose of RAG, how exactly it works. So guys, now let's understand the full flow of RAG architecture in two phases. So now let's put everything together. Let's look at the complete RAG architecture. And the thing to understand here is that RAG actually work in two distinct phases. Phase 1 is the indexing phase. Phase 2 is the querying phase. Let me walk you through both. So phase 1, indexing. This is the setup phase. You do this once at the beginning. So when you first set up your RAG system or whenever your documents are updated, here's what happens step by step. So step 1, you load your documents using the document loader, PDFs, website, whatever data source you have. You pull the raw data, right? So in step 2, you split all that text into a smaller chunks using the text splitter, right? Remember, those index cards we talk about, this is where you make those index cards, okay? Then in step 3, you pass each chunk through the embedding model to get its vector. And in step 4, you store each chunk, both the text and its vector, in the vector database. After that, your knowledge base is ready. Your RAG system is set up. For a small PDF, these might take 5 to 10 seconds. For a large set of documents, maybe a few minutes. But you only do this once. After that, it's ready to answer the question forever. Well, until you update your documents. Phase 2, querying. So in this, what happens every single time a user asks a question in a real time. So in step 1, the user types a question. Simple. Step 2, we take that question and convert it into a vector using the exact same embedding model we used during the indexing. So this is the very important. It has to be the same model or so the vectors are in the same mathematical space. Alright? Then step 3. So we send that question vector to the vector database, which searches through all the stored chunk vectors and returns the top 3 to 5 most similar chunks. I hope guys you all are getting what I'm saying. Alright, cleared? Okay, let's jump to the step 4. So we take those retrieved chunks and plug them into our prompt template along with the user's original question. Okay, then step 5. We send that complete structured prompt to the LLM, and in the step 6, the LLM reads the context, then thinks about the question and generates the final, accurate, and grounded answer and sends it back to the user. That is simple. It's very simple. See, don't be confused. It's a very simple. Then the entire querying process from the moment you type your question to the moment you get your answer happens in just 2 to 5 seconds. That's it. That's enough. Okay? So guys, think of it like a cooking show. The indexing phase is like the chef doing all the prep work before filming and chopping the vegetables, marinating ingredients, organizing everything. So, the querying phase is the actual live cooking where you take the prep ingredients and turn them into a meal in minutes. So, in 2 phases, one incredible system. So, that is what the RAG architecture works. I hope you completely understood the point what I explained. Alright everyone, that is a wrap on video 2. Honestly, give yourself a moment because what you just covered in this video, most people who call themselves AI enthusiasts don't actually understand this deeply. You now know what is machine learning is. You know deep learning and neural network. You understand the embeddings. Really understand them. You know LLMs, vector databases, transformers, and also prompt engineering very well. And top of all that, you know what is RAG, why it was created, and all 5 of its components, the complete 2-phase architecture of RAG, and exactly where it fits in the bigger GenAI and agentic AI world. So that's a serious foundation, and we are just getting started. Alright, so guys, in the next video, and this is the one I know you're waiting for, and we are going to build a complete RAG application from scratch. LangChain, OpenAI, ChromaDB, live coding, end-to-end projects, and you will have working a RAG app by the end of it. So please guys, do subscribe if you haven't already and hit that bell icon because you don't want to miss that one. And if this video is really help you, so please drop a like and do comment in the comment section what you want in next video. So it takes 2 seconds and it genuinely helps the channel reach more people who are trying to learn these same things you are. And also I want to hear from you in the comment section. Tell me which concepts today was brand new for you, and was it the embeddings, was it the vector database, was it the difference between indexing and querying? So please guys, let me know. I read every single comment, and this is the Sheetal. Thank you so much for being here, and I'll see you in the next video. Take care. Thank you.